Hello friends, in this session we will learn the sampling techniques. Now see introduction part. So what do you mean by population? Very simple. See, population means simply all the item that are to be studied is called as the population. What is population? Simply all the data which you are having and which you are using for the purpose of study, that is called as population. So what is population? Simply all the data you are having, we call it as the population. Now what is sample? The part of population we call it as a sample, right? So the portion selected from the population for the purpose of study we call it as a sample, right? So sample is very simple, it is a part of population. Now see, we can describe the samples and the population using the measure. It can be the mean, median or the standard deviation. So the terms used for describing the population we call it as the parameter, and the terms used for describing the sample we call it as the statistics, right? So in that way, remember, P for population, P for parameter, S for sample and S for statistics. In that way you remember. So simply parameter is the characteristics of the population and statistics is the characteristics of the sample. Now see in detail. See, all the item that are to be studied is called as the population. What is sample? Sample means simply a portion selected from the population for the study is called as the sample. Now we can describe the sample and the population using the measure. It can be the mean, median and the standard deviation. We will discuss it in detail later. Now when we describe the term, when we describe the sample or the statistics, the term used for describing the sample we call it as the statistics, the term used for describing the population we call it as the parameter, right? Remember, S for statistics, S for sample, P for parameter, P for population. So simply statistics is the characteristics of the sample and parameter is the characteristics of the population. Okay. Now see, what is population? Simply all the item. What is sample? Simply the part of population. So P for population, P for parameter, S for sample, S for statistics. So there are different symbols used which will be useful when we solve the numerical. For population size, capital N. For sample size, small n. For population mean, mean means simply the average, it is mu. Sample mean, it is x bar. Standard deviation sigma and standard deviation of the sample is S. Now see, there are different types of the sampling. First, we will classify it as a random sampling and non-random, that is the judgmental sampling. So non-random sampling also called as the judgmental sampling. So what is random sampling? Randomly you are selecting one sample, right? Randomly. Now what is judgmental sampling? So if you are selecting the sample based on some judgment or based on some criteria, or you are applying some your own logic, when you are selecting the sample out of the population, we call it the non-random or the judgmental sampling. Now we can classify random sampling into 4 categories: simple random sampling, systematic random sampling, stratified random sampling and cluster sampling, right? There are 4 types: simple, systematic, stratified and cluster. Now see in detail one by one. What do you see? There are 2 types of sampling. First is the random and non-random, right? So what is random? Random sampling is also called as the probability sampling. So in random sampling, sample is selected in such a way that every unit in the population has equal chance of to be selected. This method is called the probability or the random sampling, right? So what is probability or random sampling? You are selecting sample randomly. So obviously every item will have chance of getting selected. Now what is non-random sampling? It is also called as the judgmental sampling. So if the sample is selected using some criteria or the judgment, then this method is called as the non-random or the judgmental sampling. So for example, if you are having lot of samples, right? So you in a population we are having, for example, the students, right? So there are 100 students, right? So you are choosing the students which you are living nearby you or which are neighbors to you, right? That means you are applying some criteria or judgment, right? That means you are applying some criteria or the judgment while selecting the sample. This is the non-random or the judgmental sampling. For example, if you have to select the students from the lot of students, right? If you have to select, for example, 10 students out of 100 students, so 10 students you are selecting which are neighbor to you. That means you are applied the criteria of neighborhood, right? Now we can classify the random sampling into 4 categories: simple random sampling, systematic, stratified and cluster. Okay, now see one by one. What is simple random sampling? See, this method allow each item in the entire population have equal chance of being selected or being included into sample. For example, if you are having 10 items, right? If you are taking out one sample, right? And so every item out of 10 items will have the equal chance of getting selected. So because you are selecting it randomly. Okay, now we can classify it into 2 categories: with replacement and without replacement. See, sampling without replacement means what? While drawing multiple sample, if we remove the already sampled items, from the population for the next time sampling, we call as the sampling without replacement, right? For example, if we are having numbers like 1, 2, 3, 4 and 5, right? Now you have done the sampling and you have selected say number 3. Now when you are doing sampling for the next time, you will have only 1, 2, 3, 4 and 5. This is without replacement. So that time you can only able to select any. For example, you selected 4. For next time you will have only number 1, 2 and 5. That means whenever you, whatever sample you are selecting will not be put again into the basket. Now what is the sampling with replacement? Simply, if the sampled item again added to the same population, if we randomly take the sample, then there is chance that the item which we have picked that may be get picked again. That means it is called as the simply sampling with replacement. For example, if you have chosen sample 1, 2, 3, 4, 5, these are the data we are having. So we have done the sampling and we have chosen say again the 3. Now while doing the sampling again, we will put that 3 again into the same basket. So for next time also we are having the same data for doing the sampling. So there is chance that for next time also you can have the selection of a 3, right? That means this is called as sampling with replacement. We have chosen, put it again basket, so again it can be selected. That is called as the sampling with replacement. This is with replacement, this is without replacement. Okay, now see what is systematic sampling. It is also called as in systematic sampling we generally select every nth element. So in this, elements are selected from the population at a uniform level. At a uniform level we are selecting the items. So that can be in the time order or space. It can be measured in time order or space. So this is all sample. So in this, all the samples are not having equal chance of being selected, which was there in the previous, right? So in this sampling, only first unit in the sample is selected at random and rest will follow some systematic pattern. Very, very important, right? So first unit we will select randomly, and lastly and after that we have to follow some systematic pattern, right? For example, say we have to choose, we are having, for example, say the numbers from 1 to 100 we are having numbers, right? And we have to do the sampling out of that number, right? First we will select any number, say 7 we have selected, right? Then after that, this is 7 which we have selected it randomly first, because it is the first element. Now we will apply the logic after selection the first element. Say every 10th element we will select. So after 7th there will be the 17. After 17th, next 10th element will be 27. After that 37. After that 47. That means after selecting the first element randomly, you have to apply the logic. Say every 10th element we are going to select, right? That is called as the systematic sampling. Very simple. Okay. Now next is the stratified sampling. So in stratified sampling, what we do, we divide the entire population into the strata. Strata means simply the group, right? So we are having lot of data. We will divide that data into the groups, right? And each group we will call it as a strata. Okay. So the sample we will take from the strata. From that strata we can take the samples now. For example, we are having the strata. For see how we are having the population of a mark students gets from 0 to 100. Now that 0 to 100 marks we will divide into different strata, right? Say 0 to 30, then 31 to say 50, then 51 to 80 and 81 to 100, right? This is the strata. So group we have created, right? That is what the strata. Now one thing you note, right? So students which are getting marks 0 to 30, they are less clever. We can have some judgment, like students which are getting marks 81 to 100, obviously they will be the top class students, right? That means we can say the students which got 81 to 100 marks will be having same level of IQ, or they are clever. That is, their IQ level is same, right? And students are getting marks 0 to 30, right? Their IQ level are same, right? That we can make judgment, right? That means within the strata, within same strata, variation will be very less. And say for example 81 to 100, the very clever students, so they will have same homogeneous nature of characteristics, right? So we can say within the strata the same quality will be there, that is homogeneous. And between two strata, so can you compare the students which are getting marks 0 to 30 and which are getting marks around 100? So there is large variation between the two strata. So between the strata there is a heterogeneous nature. So you can see here we are creating the strata which are homogeneous in the nature. If we compare two strata, there is lot of variation, right? For example, we are having population. So we create the population of a male, we create the population of a female and separate it from the children. That means male, female and the children, there will be the three strata we are having, right? So all men will have the identical characteristics, all female will have the identical, and children will have identical characteristics. That means within very very important, for within the strata variation is less, and between the two strata variation is more. Now next is the cluster sampling. Again the same thing, but very interesting logical differences there. See, in cluster sampling we divide the population into the cluster, then sample we will take from all the clusters, right? For example, if we are having the Indian student, we are having the data of Indian student, we will divide that into the cluster, say Maharashtra, MP, Tamil Nadu and Kerala. So in 4 we can divide it, and from each cluster we will take the sample. So within the cluster variation will be high, and between two cluster variation will be less. So this is just opposite to the stratified and cluster. Very very important, again for exam point of view. See, we are having the population, so we divide the population as per the state. See, this is the population of Maharashtra, this is say Kerala, this is say for Tamil Nadu. So see, population of Maharashtra and population of Kerala, so there is a very small variation between that two, right? But see, but we can say within the Maharashtra variation can be more, right? So only one thing you remember, see, for stratified the strata are having homogeneous in nature, but for a cluster, within the cluster there is high variation, so we can say it is the heterogeneous in nature, right? So that two things are very very important for exam point of view. See, strata, in strata items are homogeneous, but in cluster items are heterogeneous, right? Okay, now see how question can be there. A type of sampling which is appropriate when the population is already divided into the group of different sizes and samples are drawn need to reflect the characteristics of the population. It is stratified sampling, systematic sampling, cluster sampling or systematic sampling. See, when we want the exact replica of the population into the sample, we have to follow the stratified sampling, right? Option number first is correct. Why? Because in strata we are having the items, we are selecting the samples from the strata, and strata are homogeneous in nature. Strata are homogeneous in nature, right? Strata are homogeneous in nature. So if we select the sample, right? For example, say if we are having the population, right? This is our, for example, the population, right? This is our population. So we will create the strata of the same. See, this is strata 1, this is strata 2, this is strata 3. This is the red, blue and green, right? This is, see, items within the strata are identical, all are red. So we select for example, we have selected the red, we have selected the blue, we have selected the green. So this will be the part of sample now, right? That means this is the items within the strata, they are homogeneous in nature, right? So when we want the same replica of the population as a sample, we have to follow the stratified sampling. Now see, what is the sampling distribution? See, we are having population. So from population, we select the samples, right? These are the samples selected. Now we find the average of each samples. So average means simply the mean, that is x bar, x1 bar, x2 bar, x3 bar, x4 bar. So these are the mean of sample. So if we plot the graph of a mean of a sample against the probability or the frequency, we will get this type of a bell-shaped curve. This is nothing but the sampling distribution, right? So we will see in detail what is sampling distribution. It is nothing but the distribution of all possible value of the statistics from all possible samples of a particular size drawn from the population. If we distribute the sample against the frequency or the probability, we will get the sampling distribution. Sampling distribution means simply we are distributing the samples, right? And from that we are able to know how many samples at the right of the mean, how many samples at the left of the mean, right? That is what simply the meaning is standard deviation. So this is the mean, your sample is here. So how far it is from the mean? If your sample is here, right, how far it is from the mean, the distances we are able to get, that is nothing but the standard deviation. Okay, we will see when we solve the problem, at that time you will get the better clarity. Okay, now see, what do you mean by variance, standard deviation and the standard error? So variance basically represent the spread of the data point from the mean. Mean, for example, if you are having, this is the mean, and if you are having the data here, say, so what is the distance of your data from the mean? It is called as the variance. Variance means vary, how much it vary, right? If this is identical line and if your data is here, how much it is away from the line, it is nothing but the variance, right? So more the variance, simply more the spread. This is the formula we will use when we solve the problem. Okay, no need to worry about here. At that time only I understand the concept. When we solve the problem, at that time I will use the formula. Now what is standard deviation? Standard deviation simply used, right, to measure the variance. So formula is very simple, it is under root of variance. So standard deviation is nothing but the square root of variance. So it tells you how much data typically deviate from the mean. Again the same, but see, represent variance is just a representation. If you apply some mathematical on it, you will get the standard deviation. What is standard deviation? Square root of variance. So for example, see, if variance is say 68%, so data point will lie here, right? 68 both side. In that way, we will have the visual representation. Okay. Now, what do you mean by the standard error? See, it estimates the how far sample mean likely to be from the true population mean. Means what? If you are, see, we are doing calculation on sample. So this is the identical population mean. Now, if your population sample mean is like that, means how your sample mean is different from the population mean. For that purpose, we calculate the standard error. So ideally, it should be standard error should be minimum, right? So we are having formula for standard error is sigma upon square root of n. So all we will see in the numerical problem. Now, what is variance? Simply, variance is simply the spread out your number from the average. Means what? It measure what is the spread there in the number from the average. That means from mean, from average, how the data numbers are spreaded. What is standard deviation? Simply, it is the most common way to measure the spread. That is nothing but the square root of variance. What is standard error? It measure how accurately the small sample represent the population. So how your sample is representing the population, it is given by the standard error. If error is more, less representation. So smaller standard error means obviously your sample's result are likely to be very close to the average of the population. Now one thing you note here, if you increase sample size, what will happen? See, this is the population and you have taken the sample which is equal to the population. So obviously whatever you do the calculation on sample will be the similar to the population, right? So standard error will be 0 when you increase the sample size equal to the population size. If your population and sample both are equal, obviously your error will be 0, right? So standard deviation of sample again will become approximately equal to the standard deviation of population, provided that population size equal to the sample size, means small n is equal to capital N. At that case, standard deviation of both will be equal for population and samples. Very simple. So ideally, what should be the ideal position is what? Maximum number of samples should be chosen, right? Now see, formulas for standard error. See, for finite population, infinite means what? Which is very high or not countable. It is infinite. So standard error is given by sigma upon square root of n, where sigma is nothing but the standard deviation and n is nothing but the sample number of sample size. If the population is finite, means if they have given that we are having the survey of 1000 people and out of that we have selected 100 for the sample. So capital N will be 1000 and small n will be 100. So in that case, we have to use the finite population multiplier. What is finite population multiplier? This is the finite population multiplier, which is the under root of capital N minus small n upon capital N minus 1. So capital N is the sign of population and small n is the size of sample. This is called as this is called as the finite population multiplier. When both n are given, you have to apply simply the same formula. You have to multiply the finite population multiplier. Very simple, right? Now see, sampling fraction means what? How many samples you are selecting out of total sample. It is called as the sampling fraction. Very simple. So it is nothing but the small n upon capital N. Sample size upon population size. So if it is less than 5% or 0.05, that is 5%, then we can ignore the finite population multiplier. If the sampling fraction is less than the 5%, that is 0.05, then we can ignore the finite population multiplier. That means this factor you can ignore. Okay. Now see further. See, through problem you will get idea. See, the average mark of the student in a class is 60. So when they talk about the average marks, right, that means they have given the average, right? So we can say the x bar will be say 60. Now standard deviation is 9. So standard deviation means simply sigma they have given is 9. Now they are asking if sample is 100. Now see first question. If sample of 100 means what? Small n is equal to 100. Then sample of 100 students is taken for a calculation. Find the standard error. So what is standard error? Standard error, we are having the formula. What is formula? It is simply sigma upon under root of n. So what is sigma? Sigma is 9. Under root of n is 100, right? So it will be the 9 divided by 10, it will be 0.9. Very simple, right? Now see the second problem. See what they are talking, sample of 100 students is taken out of total 500 for the calculation. Now see what they have given. They have given that the small n is again 100, but total population capital N they have given 500. So in that case, what will be the formula? Standard error will be again the sigma upon square root of n. Simply you have to multiply here with the finite population multiplier capital N minus small n upon capital N minus 1. So simply this part we have already calculated here, it is 0.09. So 0.9 multiply with the finite population multiplier. So it will be under root of what? It will be capital N is 500, small n is 100, small n is 100, right? So upon 500 capital N minus 1. So it will be 0.9 multiply. You can use the simple calculator, right, for solving this, and you will get here around 0.8, right? So in that way you have to apply the logic. Only thing is what? Simply what is standard error? It is sigma upon square root of n. If both n value is given, simply use standard error is equal to sigma upon square root of n multiply by square root of n minus n upon n minus 1. Okay, so see the next problem, again very interesting problem. See, a sample, the survey of 100 customer were asked to provide their feedback for the banking services. They were asked to rate the bank on scale 1 to 5, and 5 is the best, 1 is the least. Now random sampling method is used to build a sample of 5 responses out of the many responses. So here sample size is 5 and total customers are 100, right? Selected responses are 2, 3, 3, 5, 4. These are the rating got. Calculate the standard error of the statistics and find the variance. So friends, this is very interesting. I will give you the solution. See, how many samples are there? Samples are 5, right? So we are having x is equal to x, right? What are the samples we have chosen? 2, 3, 3, 5 and 4. These are the sample, right? Now from that you can find the x bar. So what will the x bar? X bar we see simply summation of n. So 2 plus 3 5, 5 plus 3 8, 8 plus 5 13 plus 4, right? So it will be 17, right? So simply find the x bar. So x bar will be, you will get the x bar as a total summation of it. So it will be 9, 9 plus 3, 9 plus 3 12, 12 plus 3 15 plus 2, it will be 17. So 17 divided by how many numbers? So here n is 5, right? So divided by 5. So x bar you will get here say 3.4, right? So 3.4 is the x bar, is the mean you got here, right? Now what you have to do, next thing, simply find the mean. This is x bar. Now in the next step, find the x minus x bar, right? So 2 minus 3.4, 2 minus 3.4, you will get here the minus 1.4. 3 minus 3.4, you will get here the minus 0.4. 3 minus 3.4, you will get simply the 0.4. 5 minus 3.4, you will get simply the 1.6, right? And 4 minus 3.4, you will get 0.6. This is the value of what? Value of x minus x bar. This is value of x, this is x minus x bar. In the next step, you have to do the squaring of it. That means x minus x bar square you have to find, right? So simply do the squaring. 1.4 square, it will be 1.96. Square of 0.4 will be 0.16. Square of 0.4 again, it will be 0.16. Square of 1.6 will be 2.56. Square of 0.6 will be 0.36. This is the squared value. Now simply do the total. Summation of it you will get here. The summation will be say the 5.2. So we have calculated x minus x bar square and summation of x minus x bar square. So it will be 5.2. Now what is variance? What is variance? Variance is nothing but the sum of squares, sum of a square divided by n minus 1. So what is sum of square? This is 5.2. So it will be 5.2 upon n minus 1. N is 5, so 5 minus 1. So it will be 5.2 divided by 4. So you will get here around 1.3. So 1.3 will be your variance, right? So this is your variance. So variance is 1.3. Now next is what? Standard deviation. What is standard deviation? Standard deviation is nothing but the square root of variance. So it will be square root of 1.3. It will be 1.14. So standard deviation you got here the 1.4, right? This is 1.4 is standard deviation. Now in next step we have to find the standard error. What is standard error? Standard error is nothing but the sigma upon square root of n multiply by capital N minus small n upon capital N minus 1, and it is in the square root. right? So simply put the value. What is sigma? Sigma is standard deviation, which we have calculated, right? So it is what? Simply it is the 1.14 upon square root of n square root of 5. Simply here put capital N. Capital N is 100, right? Because we are conducting the survey of 100 customer, right? So capital N is 100 minus small n is 5. Number of samples are 5 divided by again 100 minus 1, right? So simply solve. You will get here 0.51 multiply by 0.9796. So it will be around 0.499. So this is your standard error, right? So this is your standard error. So in that way, you have to apply the formula in the examination for solution of this kind of problem. So generally they are asking this type of problem. So I will mark as an important problem. This is start question for exam point of view. Okay. If you need solution, you can check out here, right? First we have find the x value written, then we have mean is 3.4. Simply x minus x bar we have calculated. Squaring it, doing the summation of squares, simply you will get the variance. So sum of square divided by n minus 1. Then standard deviation is square root of variance, it will be 1.14. Simply use the formula sigma, standard error is nothing but sigma upon square root of n, and multiply with the finite population multiplier, you will get the result, right? Now what is central tendency? See, a measure of central tendency is a single value that attempt to describe a set of data by identifying the central position within the data set. For example, see, if you are having lot of data, if you know one point, that one point will be able to describe all the data, that is nothing but the central tendency. So in simple word, central tendency is what? It is nothing but the middle point of the distribution which represent the entire population of the sample. So what is central tendency? Central tendency is nothing but the middle point representing the entire population. So see, mean, median and mode, these are the measure of central tendency. So they will ask you which of the following is not a measure of central tendency. So remember, mean, median and mode, these are the measures of the central tendency. Okay. Now see, all about mean, median and mode we will discuss in next chapter, right? How to calculate mean, median, mode, etc, right? All the formula. Now binomial distribution. What is binomial distribution? It is the probability of distribution that have only two possible results. For example, if you toss the coin, you will have either head or tail. In the exam, you can either pass or fail. There is no middle way, right? So when we are having only two possibility, P means say the probability of passing and Q is the probability of failure. So Q is nothing but the 1 minus P, right? So P is the probability of success, Q is the probability of failure, Q is equal to 1 minus P. Right? Very simple. What is binomial? Bi means what? 2. So binomial means what? 2. Only two possibility, either pass or fail, either head or tail, like that. Okay. Now see, using binomial distribution, we are having some formula. For a calculation of mean using binomial distribution, mean is nothing but the mu is equal to n into p. P is the probability of success. Variance is given by sigma square, that is nothing but the p n into q. Standard deviation is square root of p n into q. See, standard deviation is simply, what is the standard deviation? It is the square root of variance. So that's why square root of p and q is nothing but the standard deviation, right? What is standard error? Square root of pq upon n given by the standard error. Okay, see the problem, we will get the idea. See, one of the region of the bank, in the one of the region of the bank, there are 6 managers were there, which were qualified out of 40 managers for dinner with the zonal manager. So in one region there are 40 managers. Out of that only 6 were qualified for the dinner with the zonal manager during the campaign. Now we have to identify the proportion of the qualified. Who will qualify? The proportion. See, proportion is very simple. What is proportion? So 6 are qualified out of 40, right? So what is proportion? Proportion is 6 out of 40, right? So 6 out of 40 means simply proportion will be 0.15. This is the proportion of success. This is the value of P. Then what is probably, so what is, see, for first question, estimate the proportion. So answer will be 0.15. Now calculate binomial standard deviation and calculate the standard error. Okay. Now see, how to find, see, what is we are having for standard deviation. Standard deviation is given by the sigma is nothing but the square root of p q into n, right? So what is p? P is probability of success. So 6 are chosen out of 40. So p will be 0.16. What is q? Q will be 1 minus p, right? So it will be 1 minus 0.16. So it will be, say, your value of a q will be here 0.85, right? So we got here the value of a p 1.16, the value of key 0.85. Simply put the value, right? So simply square root of p is 0.16 multiplied by q is 0.85 into n. N means total number of samples, right? So n is here 40, right? Yeah, 40. So simply solve, you will get the answer, right? So you will get around 2.26 will be your standard deviation. Now from standard deviation, once we calculate the standard deviation, we can find the standard error also. What is standard error? To find the standard error using binomial distribution, we are having the formula. What is formula? Simply square root of PQ upon N. So what is P? P is what? Again the same, 0.15 we are having, right? 0.15, right? 0.15 here. So for Q, we are having 0.85, right? So divide it with N. What is value of N? N is 40 here, right? Simply. So when you solve, you will get the standard error here, which will be simply solve, you will get the standard error 0.056. Very simple, right? So only one thing you need to remember the formula. So for a binomial distribution, we are using the value of P and Q. P is the probability of success, Q is the probability of failure. Standard deviation is nothing but the under root of PQN, and standard error is nothing but the under root of PQ upon N. Okay. So see, very simple. For finding the error, divide it by N, and for a standard deviation, simply multiply by N. In that way you remember, compare and remember. Okay. Next C problem, very interesting. So these are the basically probability based problems we have to solve. See what they have given. Bank calculate the individual saving account are normally distributed with the mean of say 2000 rupees average balance. Standard deviation is 600. If a bank take the random sample of 100 account, what is the probability that the sample mean will lie between 1900 to 2050? Value of Z 1.67 and value of Z 0.83 they have already given. Now it is very interesting. See what they have given. They have given the mean of sample. What is mu? They have given 2000, right? Now standard deviation sigma they have given 600. Sample of 100 means small n they have given 100. They are asking the probability. What is the probability that the mean of sample means probability mean of sample probability x bar will lie between the 1900 to 2050? That we have to identify. Okay, this is the question of probability, right? Now see, in that case, how to solve? See, we can draw here graph so that you will get the better idea. See, this is the ideally mean means central value. So central value they have given 2000. So they are asking probability that the value will lie at 1900 to 2050. If you draw the graph, that means it should look like that, right? This is the central position mean. So what is the chance that if we select the sample, that will lie between that region that they are asking, right? Now see, in that case, how to solve? See, first we will find the standard error. What is standard error? The formula we are having for standard error is sigma upon under root of n. Simply put the value. Sigma is 600 and n is 100, right? So you will get here 600 upon 10. So 60 will be your standard error, right? So we got standard error as 60. Very simple. In the next step, we have to find the z. That is value. What is z? Z is nothing but the, what is z? Z is nothing but the your x minus mu upon your sigma x, that is standard error, right? So we are having value of z, value of x we are having two value. First is 1900 and second is 2500, right? So for both value we have to find the z. So we will take as it as a z1 and z2. So z1 will be 1900 minus mu is 2000 divided by the standard error 60, and z2 will be 2050 multiply minus 2000, that is mu mean divided by 60, that is standard error. So z1 value of z1 will be minus 100 upon 60, so it will be say minus 1.67. Value of z2 you will get here say 50 by 60, right? So it will be say 0.83. So this is the value of z1 we got, this is the value of z2 we got, right? So this is minus, you have to ignore the value of the sign here, right? But for z 1.67 they have given the value 0.4525, right? So for z1 the value they have already given probability value 0.4525, and for z2 0.83 they have directly given 0.2967, right? So that both value they have given. So z1 represent this point 1900, right? So here is 1900, here is 1900. So z1 represent this point. So this is the value for z1, this is the value for z1. What we have to identify? We have to identify that will lie between them. So z1, this is the region for z1, this is the region for z2. So we have to add, then we will get the full data, full coverage, right? So when we add a value, right, we will get the total value. It will be 0.8 7492. So answer will be 74.922% is the chance that the value will lie between 1900 to 2500, right? So in that way you have to solve in the examination. So sometimes if they have not given the right value of z, how to find that from the probability table, I will tell you. See, for 1.67 we have to identify the value of z. So 1.6 is here, next digit is 1.67, right? See here, we have to identify 1.67. So 1.6 here, right? So next is 7. So for 7 you can look after here. So corresponding value will be 0.4525. For 0.83 we have to identify. So 0.8 is here, next value is 0.83. So 0.8 is here, 0.3 we have to identify. So 0.3 table is here. So corresponding value is 0.2967. So in that way you have to see in the probability table also. Okay. So friends, here is the end of this chapter. You can download the application. Bankers Zone CAIIB is the name of application. You can simply search at the Play Store. Right? If you are having any doubt, you can WhatsApp us 9054538247. This is our WhatsApp number. Thank you.